What's up, players? It's again time to get back to some pop, another server drop series, and today we're going to pop Steel Mountain from TryHackMe. So we can see here Steel Mountain is a Windows machine, so we're going to learn about enumerating some Windows machine stuff, gain initial access using a tool called Metasploit, and we're going to use also some PowerShell for some net web client goodness. To kind of preface what we do with this particular series, I approach it as the fact that you haven't seen the other videos in my series and that this is you're kind of brand new to this. So this is for all levels of experience because I will try to explain what I'm doing. So when I see capture the flag or read write-ups, things like that, they usually do pretty good to kind of describe what they're doing, but they don't go into super detail because it's not necessarily them trying to teach or do like a course of it or something. For me, I like to take the opposite approach and actually teach hacking through this techniques. And what I'd like to do is kind of get away from the script kiddie nonsense and actually show you the methodology of what we're doing when we're popping the box, and also to explain like the commands. I won't just tell you, hey, just type all these commands in and leave it at that. I'll explain the switches that I'm using and why I'm using them, that sort of thing. So that's the goal of this particular series. And if I explain something in one video in my series, I'll explain it again in each video because, I'm taking the approach that this is the first time seeing a video, and we want to kind of take it from a beginner's perspective, if you will. Now, today's topic is going to have some advanced stuff, a little bit more advanced than just your basic beginner things, but I'll try to explain it as best I can. I also include a full document with a write-up of with screenshots and such on the same page on my website, shikataganai.com, which you can find all of my material as well. So with that said, we're going to go ahead and get popping. All right, so Steel Mountain. So we're going to be doing Windows this time, not Linux. Very cool, very cool. All right, so I went ahead and ahead of time started an Nmap scan. So let me kind of explain what this is all about. So typically, when you start to attack a machine or a CTF, if you're doing it from a virtual machine setup where you have one VM and another VM, typically you want to go ahead and do something like a net discover to ARP onto the network, which means broadcast on the network to find all the different IPs that are on the same network. And that's how you'll get the IP address of the victim machine that you're going to be attacking. In the case of TryHackMe, you log in and you have the free accounts, but you start up an open VPN connection. They tell you what the IP address is right here on the page, so you don't need to do that step. So the next step after that would be to run an Nmap scan. Nmap is a port scanner, and what it basically does, if you're not understanding what ports are kind of like my entry point into the computer, and there's 0 through 65,535, I think is the number, something to that effect. You think of it like this: if I have a web server that is waiting for a connection from me, and it's let's just say it's unencrypted, it's going to listen on port 80. Okay, that's a well-known port. The first 0 through 1023 ports in that massive range of 65,535 are what they call well-known ports for things like 22 for SSH, 21 for Telnet. I'm sorry, not Telnet. 23 for Telnet. 80 for HTTP, that sort of thing. And the ones that are, 1024 on up to about 45,000-ish is going to be what they call registered ports. And what that means is you have companies out there that may have an application that runs on a specific port. Cisco may have a particular application that runs on one particular port. It'll pick and it will register that port with a company called IANA, and that will be considered what they call a registered port, kind of reserved, if you will. And then after the 45,000-ish area on up to 65,535, those are what they call dynamic. In other words, those are created by the computer when they're going out to port 80, for instance. It will randomly generate a port from that range. So with the Nmap, it's a port scanner which will let me go ahead and scan a service or another server and see what ports are open. I want to know if a server has port 80 open or port 22 for SSH, something like that. So Nmap has a variety of different scripts of probes that it does to determine if there's something running on there. And you can add switches to them to do a few more things like the ones I'm going to show you here. So let's explain what I've got going on here. So first I run Nmap and then I do a tack-n. When I say tack, I mean dash. So this one here says disable DNS resolving, so it speeds up the scan a little bit because I don't need to know the DNS host name. I've got the IP address. Tack P, now keep in mind this is case sensitive. So tack capital P, small case n means no pinging or ICMP. You'll find when you start to do an Nmap on a particular address, it may not let you finish the scan because it's blocking ICMP. That will say, well, don't do ICMP. Tack S capital V says do a version scan. Now, if I didn't add that and I just did an Nmap and the IP address, it would tell me, for instance, port 80 is open or port 135 or 3389 or whatever. But it wouldn't actually tell me the exact version that's there. And again, it uses these little scripts to probe with fingerprints to find out, to see exactly what it is with a pretty high degree of certainty. For example, here, port 8080 is open. If I didn't include S capital V, I wouldn't know this information right here where it says HTTP file server 2.3. Okay, that's going to be important for me. The other one that's here, tack S capital C, is to say there's some scripts that you can add to Nmap to give it more functionality. You can get it some exploitation functionality. Look for specific things like SMB or what have you. And there's a section or a category of scripts called default, which are determined to not be invasive and break everything. And it's scripts you would typically run on just a regular engagement. So that command, S capital C, will actually run everything that's in the default category. For example, this is a script in the default category called HTTP methods. I could put it in there manually in my command, but by doing this, it'll run it for me there. Also, these other ones that you see here, these are also scripts that are in the default category. Okay, and then followed by the IP address, which is the victim. So let's take a look at what we got here. So we see we got port 80 open. All right. And we have, let's see, it looks like an IIS 8.5. Site doesn't have a title. Interesting. So the first thing we'll do, whenever you see port 80, I always recommend go into that site. So let's just see what's on there, see if there's anything juicy, anything good. So let me pop on over here and paste. All right, employee of the month. Who's that guy? So here you can actually go ahead and right-click and inspect or view page source. And what you would be looking for in this case would be comments, be little green markings. And comments will usually indicate there may be something like a password that they left in there by the developers accidentally or intentionally. And that's what you would look for and do view source. In this case, we can glean some information. For example, we can kind of guess there's a guy named Bill on this machine because we see Bill Harper here and we know that. But other than that, I don't really see anything worth looking at on this page here. So we'll just leave that alone. Now, before I get started, let me tell you about this. And again, I keep saying every video I want to make a video on this, but I will make one very, very soon. I use this Dradis Community Edition to store methodologies. Typically, it's used to upload pen test reports, things like that. But I like their methodology way to do things. And what I usually do is I have, for instance, here, I got a little cheat sheet where I can click on some, like say if I want to look for headers, here's a command that I can run. Because a lot of times I just forget commands and the switches. So it's a lot easier for me to just go here and actually do it. If I want to look at some hashing, right, I can do that one. If I want to find, I don't know, some password cracking stuff, I go here, and here's some ones there. Here's some John the Ripper. So it's just an easy way for me to have it at my fingertips, all these different cheat sheets, as it were, so I can just copy and paste, because I fat finger a lot. So for this particular one, I actually made a separate methodology just for TryHackMe. And in this one, I'm doing Steel Mountain. So just to make the video go smoother, I've already put all of the commands in here, and I would just basically copy and paste them over. Okay, so we already did that. Let's go back here. So the next thing would be whatever the next step is. So let's come back over here. Where are we at? Here we go. So we know we don't have anything on port 80. Not really worried about that. We see 135, 139, 445. That's some SMB stuff there. Here's RDP 3389. And interestingly, there's another HTTP server down here. It's on port 8080, which is another kind of known port. We can see it's HFS 2.3, which I assume stands for HTTP file server. So I guess what we would do is we would kind of look for that and see what that's all about. So let's go ahead and Google this and see if there's anything good that can be found. All right, so I'll just pop that in there. All right, so I put it in HTTP file server, HTTP, and the first thing that comes up is an exploit for it. And it looks like it's called Rigetto. Now, if you're following along the TryHackMe page, I noticed this didn't, this confused me a bit. So if you're doing the TryHackMe walkthrough, they're going to ask you here, it's going to say, scan the machine with Nmap. What's the port another web server is running on? We saw that. Take a look at the other server. What file server is running? Now, you would probably try to put this in, right? And that's what I did. And it wouldn't take it. So eventually I did what I just did in a little research, found out it's named this. So to solve that particular challenge, if you do come across it, that's what you're looking for right there, okay? All right, so we know it's got something to do with this Rigetto something or other. So let's click on that, see what this is all about. So this website here is called ExploitDB, and this is where, well, exploits are. And if you want to get past the script kiddie stuff and actually get your hands dirty and doing some exploits and modifying or reading through them to understand them, this is the best site to do something like that. Now, this is where you would download the exploit, and we may do that stuff later. But we can see here the CVE number 20146287. Okay, CVE would be a vulnerability database, kind of globally run. It's kind of like what everybody goes to. They have something called a CVE and a CWE. But when you look at this exploit database, you got to be very careful about which exploit site you go to. The reason I say that is because there's no honor amongst these. And what I mean by that is other non-vetted exploit sites would have exploits, and the actual exploits themselves create a backdoor on your machine, your attack machine, for the guy that wrote the exploit to connect to. So there's a lot of problems with that, which is why it's good to learn scripting so you can look down through it. For instance, this one's in Python. If you look down through it and you kind of read through it, you can understand what's going on, and you know, okay, there's no backdoor here. Well, the good thing with ExploitDB is they have a team that just does that, checks for those sort of things. So it's one of the more reputable ones that we would use. So I recommend ExploitDB. So to not be a script kiddie, and if you don't know what that is, basically that's just some nerd that grabs something off YouTube and just blast it and not even know what it's doing, doesn't know what the switches are, has no idea about the methodology behind why it's doing what it's doing, and they're just, trying to hacksaw, oh, I hacked your Facebook, those kind of people, right? So we don't want to be that. We want to actually be elite hackers where we're actually understanding what's going on. So let's get an idea of what's going on. So first, let's check out the CVE and see if it gives an explanation of what this problem is. It looks like it's a remote command execution, obviously. All right, let's see. The find macro marker function in parserlib.pass and Rigetto file server before 2.3c allows remote attackers to execute arbitrary programs via a %00 sequence and a search action, which would be a null byte type of action there. That's what they call a null byte injection. So that doesn't give me much information. Let's see. There's some other stuff listed here as well. So let's actually look at the exploit and let's see what's going on here. Description. You can use HFS to send and receive files. Okay. It's different from classic file sharing because it's web technology to be more compatible with today's internet. Successfully tested, blah, blah, blah. Okay. So it says here you need to be using a web server hosted Netcat. Netcat is a TCP UDP type of connection tool that hackers use a lot for things like reverse shells. So more than likely later we'll be doing that. Note here as well, you may need to run it multiple times for success. Remember that for later on. And here it tells us the usage. So we're going to be running this target IP address, target port number. And if we go down through, it's a Python script. And so these are kind of like what you would consider a function in Python, the DEF. And it looks like it's doing some URL opens, and it's actually pulling in some different functions or methods from this particular library here called sys. Okay, that's where they're getting that from. We'll have to change this IP address to ours if we want to use this script, which we may do later. And then here we'd also have to change our port number that we have to something else. So it looks like it does a VB script and it runs that. So my guess is that it's going to be used to do like a command of some sort from the URL itself. That's kind of where I'm gathering it from. All right, so now we figured out it's Rigetto, HTTP file server, all good, everything's nice. So now that we've done that, let's bring up a tool called Metasploit, and we'll do it that way first. And then later, we may try some different stuff if we have time. All right, so what we're gonna do here, if you're not familiar with Metasploit, there's a few things you'll have to run for your first time running Metasploit in Kali Linux. I'm using Kali Linux OS distribution. First thing is service post SQL start. Okay, so you need to start the database that Metasploit will be using, which is the PostgreSQL, and then it needs to make MSF users for you in there in the database. I've already done it, so it won't show what you're going to see. But to get that happening, you say msfdb space init. And it will say, in this case here, it skipped all that stuff because I already configured it. But for you, it will say creating user, msfdb user, and then whatever. After that's done, you should now be able to run msf console. So this is probably one of the more popular exploit frameworks out there. So we saw that ExploitDB had a Python script that you could run and insert and modify your IP address and port and all that kind of good stuff. If you wanted to automate that without having to mess with that code specifically, you could look for that exact same exploit in Metasploit, and it will likely have it. Metasploit is always keeping up to date with any of the newest exploits that come out. So if something comes out at a Black Hat conference and there's an exploit for it, it's highly likely it'll probably be in here by a very short period of time. So in this particular case, what you want to do is you want to look for that particular exploit. To do that, you can say search, and then we'll put in the CVE number that we were looking at, which was this one right there. So we're going to look for any exploits related to that. In other words, this exploit that we're looking at here, but in Metasploit. So let's take a look for that. Boom, there it is. Look at that. So Rigetto HFS exec. So that's the one we want. It says excellent rake, which means it will most likely work. Very high probability that it will work. And it is a remote command execution. So I was kind of correct on that. So what you're going to do, excuse me, is you're going to highlight this right here. And then you're going to say use and then paste that in. So you use an exploit. Now they also have other things like auxiliaries up here. Encoders, different payloads, and we'll create a virus in a little bit. But this is how you would use it. So you hit enter, and it says no payload configured, default into to Windows Meterpreter. So in this case, Meterpreter is a command line tool in Metasploit that is a little bit better, well, a lot better than just the basic command shell. It has a lot of cool scripting in it. It's a great attack framework, or post-exploitation framework is what they call it. And the reverse TCP is essentially saying, get the person to click something or do something on their end and have the request sail through the stateful firewall. Now, a stateful firewall will say, we're not going to allow anything from the outside in if it hasn't been requested. The trick here is we're getting the user to click or download or do something and run the exploit and connect out through their firewall. In other words, it's requested. So the stateful firewall will record that saying, if anything responds back to this, in other words, our attack, then we will accept it because it's something that was requested. It's solicited traffic. This is how you would get through or past a stateful firewall in a lot of different cases. Now there are some EDR solutions that may see this, but just the basic thing. So now that we have this little prompt here, it's telling us we're in that exploit part. To find out what it's actually going to need for information to do the exploit, you type in show options. When you look at show options, it will show you the things that are required right here, and the things that are not required, but are still there. So in this particular case, 8080 is correct because that's the port it is listening on. The remote port actually should be changed. think about that. Yeah, so we got to change that to 8080 because that's what it's listening on over there. Well, let me see here. Looking for it to listen on target port. Yeah, so it's 8080. In this case, we're going to change this and we're going to change this, but we also have a payload option thing down here, which has its own requirements. In this case here being the local host. Now, something else you can do is type in the word info, and it will tell you about this particular exploit. And it says here that it's vulnerable to remote command execution attack due to a poor regular expression in the file parser lib. The module exploits the HFS scripting commands by using a null byte to bypass the filter. A null byte would basically do a termination at the end of what they call a string. And so it gives all kinds of information there. Now, the remote port in this case would be, the remote IP would be the victim. So we'll copy that. And then we say set our hosts. Now, there is our host, singular, in our hosts. So you got to be careful which one you're putting in. So we're going to say set our host. And this, by the way, is the only thing that's not case sensitive. So we can do lowercase in this. And then we're going to say set our port. And that will be 8080 because that's the one, doggone. That's the one it's listening on. So we'll say set our port. Awesome. And then we'll do our set L host. And we have to kind of look and see our tunnel address. If you're using TryHackMe, it won't be your ETH one. It'll be your tunnel address right here. Okay. So this number right there. So let's copy that. And we'll say set L host to that. And I think we're pretty good because I think, and then what you can do is you can do a show options to verify everything's filled out. It already picked 444 for its port, so we're good there. All right, so it's set that. That's good, that's good, that's good. All right, everything's good. Then what you would do is you run exploit. And hopefully we get a pop, pop, pop Meterpreter prompt. That's what we're looking for. And look at that. I should see one here in just a moment. Boom. Pop, 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 another server drop. So we're now in the machine, essentially. We have broken into the machine. So what we can do from here is we can do a shell access. Now let me show you real quick, just to kind of give you an idea what this Meterpreter is. So if you type in help, we're not going to use most of these. I'm just kind of showing you here. This one here is pretty cool. You can do this to modify the timestamp of a file or a virus that you put on the machine so they wouldn't know. You know, you can make it like it was created in the 80s or something, you know. Hash dump, you can run that with a script as well, but that will dump hashes from the credentials. This will try to get NT Authority system on Windows. Here's some cool stuff. You can record somebody's microphone on their laptop. You can record their web stream or web snap, take a picture. Here's some key loggers here. Here's some grabbing a screenshot from the victim. I mean, just all kinds of cool things here. You can do some steal token. Shell, we're going to use that one. That drops us into the actual command prompt for Windows. Yeah, so there's all kinds of different things. And this is going too. Clear the event logs when you're done. clean up after yourself. But yeah, you can see that Meterpreter is a pretty cool post-exploitation tool. What we're going to use it for is shell. Excellent. So it looks like we were correct. Remember the website we went to, there was a guy named Bill there, and it looks like, indeed, there's good old Bill. All right, let's take a look here at my Steel Mountain. So we already looked at the CVE. We looked at the ExploitDB. I already looked at the actual commands. We did all those, so that's good. Let's go down to the Meterpreter one, shell. All right, so I guess and I did this based off of the things that we actually have here for questions. So I guess we got to look for our first flag, which is a standard user one, which would be what we're in currently. So we are as Bill, so I'm guessing standard user. So let's navigate over to C:/users/Bill and see if there's anything there of use. We'll do a dir. Okay, nothing there but .groovy. Let's try his desktop. So we'll say cd desktop, and let's do a dir. Boom, there it is. So to view something in Windows, now in Linux you would use cat to view something in the command prompt. For Windows to view a file in the command prompt, you would use the word type. So we say type user.txt, okay? And pop, 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 there's your first flag, okay? All right, so we satisfied that particular one, which I think is everything. Okay, CVE, get the initial shell. What is the user flag? Boom, there it is. Excellent. All right, so next what are we going to do? Privilege escalation. Power up. When you enumerate this machine, we will use a PowerShell script called power up. All right. Now, I can't remember if I actually have that downloaded on my own machine currently, so let me do a check here. I do have it right here. So I did download it, but if you didn't have it downloaded, essentially you would just go and, well, we'll keep that one open there. You would go here and you would just look for powerup.ps1, and you would grab it, and it's part of the PowerShell Empire exploitation framework, and you would grab it from there. Okay, so we're going to be using this particular tool apparently. So let's go back and see what they want to do here. So download the script. You can use the upload command to upload the script. All right. So we're going to come back to the machine we're broken into. This is the victim machine we're looking at now, their prompt. And what we're going to do in this case is we're going to get out of the shell and we're going to use another Meterpreter command called upload. So I'm going to do a Control-C, hit Y and enter. That should bring me back to the Meterpreter prompt. Next, what we're going to do is we're going to, because I have the powerup.ps1 in my root directory of my Linux machine, I'm going to say upload, and then we'll say /root/ what is it called? Power up. I think it is case. I think this is case sensitive, but let's try it. All right, uploading. Boom. All right, so now we have that there. Let's pop back into our shell, and let's take a look and see if that's indeed the truth. There it is, right there. Powerup.ps1. Excellent. So we now have that bad boy ready to rock. So let's come back here because I always forget my commands. So we did that. And by the way, you can use a git clone as well to clone that into your machine if you have git installed. And we already did that upload. All right, so we done the PS1, got that over there. And let's go ahead and load PowerShell because we actually have to, because we're in Linux, so it's using bash shell. We want to actually use PowerShell. Part of Meterpreter's cool functionality is that it has a PowerShell agent on it that you can run, or module, whatever you want to call it. So we're going to go ahead and do that from Meterpreter. So let's go ahead and copy that. And I don't know why I keep going back to that window. All right, so we proved it was there. Let's Control-C back to our Meterpreter prompt. And let's go ahead and put in load PowerShell. All right, should load the extension for PowerShell. And while that's loading, the next one we would do is to actually interact with it and do a PowerShell.shell. All right, let's go ahead and interact with it and get a PowerShell prompt. There we go. Excellent. All right, so the next one then you would run is because we're in the same directory that the PowerUp PS1 script is in. To run it, you actually have to do a dot, space, dot, and then a slash to the left. I tried just the dot slash and it didn't work. So this one works for me. Let's try it and see, just to verify. So we're going to go ahead and do that to execute the PowerShell script. It should execute. Awesome. So it's loaded in, kind of like a module. And then from there, we would actually want to invoke all checks because the script itself has a variety of PowerShell commands it will run to do a little bit of enumeration. So let's go ahead and invoke all the checks and see if there's anything we can pop this box with via this machine. All right. So it's got a lot of different stuff here. Let's scroll up and see if there's anything interesting. So let's see. Can restart. Okay, here we go. Unquoted service path. Excuse me. So the check is that. Interesting. All kinds of these different ones in here. Let's see if we can find one. Okay, can restart. All right, so this one here, right here, Advanced System Care 9, and it says unquoted service path. So the idea behind this is in Windows, whenever you're trying to do a command and it has, if you're trying to CD somewhere change directory, and the actual directory path has a space in it. If you don't actually put it in quotes, then it will actually recognize it as a breakpoint, if you will, and it will then execute whatever code is after it. So they call that an unquoted service path if you see that. So if we look at the actual path, we can see here, see that right there? There's a space right there, and right there, and right there. So this is what's triggering apparently as an unquoted service path. And something else we want to look for is this, because here's our goal of what we're trying to do. We are going to try, and because this is modifiable, by the way, so we can do this, what we're going to try to do is we want to run a trojaned version of this executable. And the reason why is because that executable has local system privileges. So if we actually set up a reverse shell, a payload that does a reverse shell back to my attack machine, and the actual executable will be in run, has the local system privileges, well, that means I would have NT authority system, which is the top dog in Windows, if I were to get that reverse shell. So the goal is to use a tool called Msfvenom to create an actual virus or payload that I can upload here and then copy into this name as the exact same name, but it's a trojaned version of it. Kind of similar to what they just did with the Sunburst, if you've been following any of that. With the SolarWinds thing, is they actually injected a trojaned version of an update, a backdoor, if you will, into the actual build steps, which is kind of interesting. Anyways, so we know it has local systems, so that's a good one there. And a restart, what would have to happen is we would have to stop the service in order to copy a new one into it. Once that's done, it's only looking for the name, so then we would have to restart the service for the actual reverse shell to trigger. So we have to be able to have it restart, and it does do that, and it is local system. So this is our Huckleberry. This is what we want. All right, so advanced system care service 9, that's our Huckleberry, okay? All right, so good thing is I already have that already listed in my in my sweet Dradus down here. So I'm going to go back here. All right, so we did the Meterpreter. Let's go ahead and make our Msfvenom. I'll explain this after I create the virus. So let me come back over here, and I'm going to do this on my local machine, not on the victim machine, obviously, because the victim machine doesn't have Metasploit installed. Metasploit has a virus creation tool called Msfvenom, where you can make a variety of different payloads. So let me paste this in here and kind of explain what this is after I run it. Oops, I got to fill it out. IP address, there it is. So I got to put my local host, which in this case would be my this one here, the ton0, be that one. So we need to pop that bad boy in there. There we go. All right, let's try running it now. Excellent. So what it does here is you start off with a tool name called Msfvenom, and then the TACP says what payload do you want. Now you can do an options or a man page on that, and you can see there's a ton of different payloads that we're going to use. This particular one we are targeting Windows. And this is important because that's why you do an Nmap scan looking for the operating system type, because you want to make sure you're running the right payloads. If you're running Linux payloads against Windows all day long, it's just going to suck because you're not going to get anywhere. So you need to know, okay, what's the operating system I am targeting here in this case? So we pick a Windows one. And this one here will give us a command shell, not Meterpreter, just a command shell. And it's going to be an underscore reverse TCP, kind of what I was talking about before, where we're trying to go through the firewall and get it to happen that way, right? Because we're in the other guys, we're in the machine as Bill, so we're getting Bill to trigger it, so it sails through his local firewall. That's the intent, and goes out there as a stateful request. Next, it's going to look for a local host to connect back to. In that case, it would be my machine. Which in this case is this one, my local host. And then a port that we choose. I just picked a random one here, 44443, whatever. And here comes the goodness. Here comes the super sauce. TACI. Okay, this is a encryption type, right? An encoder, if you will. And this is where I get my name from, Shikataganai. It's a polymorphic encoder that will actually kind of mutate its encoding multiple times. And so it's called Shikataganai. So this is just a path to that particular, or it's calling out that particular encoder. There's a ton of them, but I gotta go with Shikata Ganai, baby. That's my name. There's nothing you can do about it. That's what it stands for in Japanese, by the way. There's nothing you can do about it. The TACF means the file format you want to rip it out into. In this case, we're going to rip it out as an exe, executable. And then the TAC-O would be the output name that we want for it. I'm just calling it advanced.exe for now. We'll screw with it a little bit later, okay? And then down here, after we run it, you can see it ran successfully. Now, you can do multiple iterations of it too, right? So you can move 20 iterations of Shikata Ganai to really encode that payload to try to get past antivirus measures. That's kind of why you do that, is to try to get around endpoint protection. All right, so we can see here, there's the payload. Let's take a look here. Advanced.exe right there. Awesome. I got to make sure some of the other files I'm going to make are not in here, which I do not see them here. Cool. So we can continue. So we now made our Trojan, made our virus. So let's pop on back here. In this case, what we're going to do is we're going to actually do a move command. Now, when you do MV for move, it's essentially Linux way of renaming a file. So I'm renaming this executable into this. And the reason why it's this is, if you recall, that back here, this advanced system care, the actual executable for it is that. So we're making a Trojan version of that. That's the idea, okay? All right, let's come back over here and let's do that move command and rename our file. This is super handy. You really got to get this Dradis Community Edition. Super awesome. Makes things go by really cool. All right, so we're going to come back to our machine, not the actual victim. And let's go ahead and move that into that executable. So we do have that now right there. Pretty cool. All right, so we're good there. Let's move on to our next one. We're going to come back to Meterpreter. Now we're going to have to actually upload that particular one to Bob's machine, right? So let's come on back over here, and we're going to go ahead and exit out of PS. Is it exit? Is it quit? Oops, I mistyped it. How about Control C? Yes, terminate channel. Okay, cool. So what we're going to do now is we're going to do our upload, and we do have it in root. So we'll say upload /root/AS, and I don't know if it will do the tab. Cool. So we're going to upload that over to Bob's machine. Bob's your uncle. All right, excellent. So let's do our shell. We're going to do a directory to make sure it's there. So let's pop back into shell. Again, this is a tool within Meterpreter. And let's do a dir to verify that it is there. And there it is. So we see it. Awesome. So what we need to do next is we need to actually stop the actual service, the legit service of advanced system, whatever it's called. And that way we can kind of copy over that particular one and then restart it. Because don't forget that it has the ability to restart. All right, so to do that in Windows, you use SC, and that has to do with services. So we're going to copy this over here. There. So we're going to say SC stop and then the name of the service. The name of the service actually is Advanced System Care Service 09. The executable behind it is ASC service.exe. So don't be confused by that. So we're going to start that. I'm sorry, stop that. Let's see, it doesn't exist. Interesting. Maybe I misspelled it. Let's go up and look. Advanced System Care. Okay, here's the service name. It's there. Oh, it's 9. It's not 09. I gotcha. All right. So let's come back down here and do that again, because apparently it's... Oh, you can't do that, huh? I guess in that shell you can't do it. So let's see if we can... Okay, service 9. There we go. And doggone it. I hate these shell things here. All right, let's just type it in. So SC stop Advanced System Care Service 9. All right, so we should be able to stop that. Bing. To verify that, we're going to go ahead and do a query. So let's come back here. And let's fix this for a second here before I screw it up again. So I'm going to change this back to a 9, and that to a 9, and that to a 9. All right, that should be all of them. And let me update that so for the next time I screw around with it. All right, so now we're going to query to verify that indeed it has been stopped. We don't want to just kind of take its word for it. So let's query it. All right, so here we can see the state is stopped. Excellent. All right, so let's move on back over here. So what we're going to do next is we're going to actually copy what we have on our machine, which is the one we uploaded to, I'm sorry, on Bill's machine. We uploaded it there, so it is there in that directory. So we're going to copy that over, and notice the quotes we're putting in, unlike what it showed up as because of the spaces. And we're going to actually copy it into this as this name. Now it's going to recognize that as already existing, and it's going to ask us, do we want to overwrite it? And I'm going to say, heck yeah, baby, let's do it. All right, so let's get our Trojan version of this bad boy over here. Come back over. Copy it on over. It's going to ask us, do you want to, where is it? Overwrite it. And I'm going to say, yes. Let's do it. I don't know if it's capital case sensitive. I'll just do it. Yes. One file copied. Love it life. All right. So next what we want to do is we had set up the original Msfvenom virus to to connect back to port 4443. So we actually need to set up a listener on that, and we can do it with a tool called Netcat. Netcat is known as the Swiss Army knife of hackers because it does multiple different things for TCP and UDP connections, but we can also catch a shell back to us, right? A reverse shell, and we can actually, in that instance, get a shell access that's on that person's machine. What we should be able to see, if this works, is we should be able to see the Windows command prompt from Bob's on our attack machine. So I'm coming over to my attack machine, not Bob's machine, my own machine. I'm saying NC, TAC N for the DNS resolving, we don't want that. L for listener. Lowercase l means not a persistent listener, but we don't really need that for this. And then V for verbose and P for port, and we're going to say 4443 because that's the one we made in our MSF Trojan for that. So it's just going to sit here and wait and listen for when things happen. Again, this is my attack machine. We're going to go back over to the victim, and what we want to do is we want to start up that service. Why? Well, first, it's stopped. Second, it has our Trojan in it. So when it runs that service, it's going to run the Trojan version of it, which is the reverse shell, and it's going to run it as system. And then hopefully our prompt, our little Netcat here, will populate with a Windows terminal that gives us the top dog status, which is NT authority system. That's our goal. All right. So let's get back over here and let's copy this over. So we're going to start that service up again. And hopefully, pop, 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 baby. Y'all ready for the pop? Let's do it. Let's see what happens. All right, so start. Bing. And wait for it to start. And I think it should be started. And there it is. So we come back here and we can see our listener was listening. And look at this. Pop, pop, pop. Another server drop. We are now in the machine. But let's see who we're in as. Who am I? Bio! Right there, NT-authority, baby. Loving it, man. Can't get any better than that. It's pretty awesome. So now that we're NT-authority system, what we could do is we would assume the administrator, because we're looking for the root, was it the root flag? Let's see what it's called here. Let me come back here to TryHackMe. Oh, let's see. We're looking for the root flag. So I would assume that's probably over, it's not Bill's, more than likely. And by the way, we're using this screen now to do our interaction because this is the one that has given us a shell as system. So we should be able to navigate into the administrators folder from here. So let's do a CD, C:/users. If I can type, is it user or users? I think it's users. /administrator. Am I spelling that right? No, I'm not. Administrator. There we go. Excellent. All right, let's see if the root flag's here. It is not, so it's probably on his desktop. Let's go take a look at the desktop. And bam! Right there. Loving it. So again, to view a file in command prompt in Windows, you would use the type command, root.txt. Pop, pop, pop. Another server drop. Loving it. All right. So that has been done with Metasploit, but I think it asks us to go a little further. Yep, right here. Access and escalate without Metasploit. Oh no, man. That means we actually have to screw around with some code. What is up with that? But that's all good. So let's do that. Let's exit out of here. I guess Control C should work, right? Yep. All right, so I'm out of that machine, not there anymore. And let me exit out of old Bill's here. There we go. Terminate channel, yes. And I'm going to exit out of Meterpreter. And I'm going to exit out of Metasploit. All right. Let's get rid of that window. We don't need that anymore. All right, so we don't have Metasploit running. None of that. We want to do it straight on because this is something you would have to do if you were to take something like the OSCP exam. I think they give you one use of Metasploit exploitation, and the other stuff on the test you have to be able to exploit without Metasploit. So it's good to know how to do it. So let's see here. So I'm going to go grab the file right here. All right, so we're going to screw with this one, 39161. And again, make sure you're reading through the code to verify there's no backdoor that's listed there. So I'm going to go ahead and download this bad boy, and we'll save it to my root directory. Actually, let's make a folder here. What is this called? I'm trying to remember now. Steel mount. Call it that. And let's put it all in here. Let's do everything from here. All right, so I'm going to navigate to that. Awesome. All right, so let's nano that. Now, nano is what they call a text editor in the command line, so it's very similar to what you would do with a graphical text editor. And there's other ones like Vi, and there's big battles that go on between people, and blood and guts and everything happen when they get into debates about it. But nano is the one I like, so screw it. So I'm going to say nano, and then we'll do the 39 tab complete. So if you start typing in something that's in that directory to get it to fill out, you do a tab, and it does tab complete. All right, so here's the Python script. Let's go down and look down through because there's something we had to change. We had to change URL, right? There it is right there. So we need to change this to our tunnel address. All right, if you're on TryHackMe. All right, so I don't remember what my tunnel address was, so let's go ahead and if config will go ahead and give you your information on Linux. And we want this address right there. All right, pop it on over here. And let's put it in there. Let's not use 443 because it may already be in use, so we just want to kind of pick more of a random port number that we can use for that. So let me see. Did I put anything in here? Let's go back here. Non-Metasploit way. 9200, that's what I picked. Okay. We can do that. That's all right. Let's do, we're back here. Let's do, instead of 9200, I don't know. We'll just pick something 4888 sounds good. So we're picking just some random port number here, and Control X, Y, and Enter will get you out of that and save that for you. Don't forget what the script said as well, that we would have to run things twice or multiple times to be able to do it. And we also need a web server running in this same directory with that sort of thing. So to do that, we can use a web server called from Python. And I'll show you kind of how we do that. So here is a web server that we'll grab. So we'll start our web server. Where am I at? There we go. So I'm in the steel mount. So if I were to go ahead and do this here, it's basically saying anything that's in this directory, we can actually give out, right? That's the idea behind it. So what we want to basically do in this case here is we want to be able to send that on over to the victim machine. Now, this particular one I think needs, I'm trying to remember now. I think it needs to see the IP address of the victim. And let me verify here just so I'm not screwing up. It's always good to come back and look at the instructions. Okay, so Python exploit, whatever the name of it is, target IP address. Okay, so the victim and then the target port number. Now in this case, the target port number will be 8080 because that's what Rigetto is running on. What this command, this script should do is it should the first time I run it, it should actually drop Netcat, a Netcat executable on the victim machine, and then the second command should actually run it, right? Should run the reverse shell. So we actually have to set up our reverse shell again, just like we did before, using the same tool. So in this one here, what I decided to do, I think, was this right here. So I just picked, what did I pick? 4. I'm trying to remember now what I just had in this script. So let me come back here real quick. I'm going to CD over to that same directory because I already forgot the port number that I put in there for it. And so I'm going to nano, or actually I just do a cat. It's a cat 391 piece. Okay, let's take a look. Okay, so I put 488. Okay, so this is the number you have to put in, the port number that you want to listen on in your Netcat. Okay, so again, we'll do NC, TAC, NLVP. Again, N for no DNS resolution, L for listener, V for verbose, P for port number, and 4888. There we go. So now it's listening on that. Because I'm sending this script to the machine, that's the one it's going to connect back to. So, well, now that we got that rocking, we need to actually have another terminal window open in that same directory. So again, come back here, steal, boom. All right, so from here now, we actually need to run this Python script. To do that, you say Python, and then the actual name of the Python script. So we'll say 391, run it one time. Oh, actually, no, I need to put, what is it? Shoot, I'm trying to remember now. IP address and 8080. So the victim is this address right here. So we're going to say Python target IP address, which is that one, and then 8080 because that's where the Rigetto server is running from. Okay, so that should be the only thing we need to run. So let's hit it once. That should have dropped Netcat on that machine. Now we're still listening over here on 4888, as you can see down here. This next time we run it, it should actually execute the Netcat that's there. So let's hit it again. All right, now let's go check. Still listening on 4888. Give it a second. All right, so I paused for a moment because I was trying to figure out what I did wrong. And first off, I forgot to put the executable in the folder, the nc.exe. So that was my bad. So I looked back here. I was thinking, what's going on here? And then I noticed I need to have a web server host in Netcat here, okay? So the nc.exe. So what I did is I copied it. Here I found the binary on Kali Linux, and I copied it into this folder. So now we have the exploit script in that. But then what I did is I ran this right here, this Python 3 at 9200, and it didn't work. So then I went back and noticed here they're specifically asking for port 80. So I figured, okay, well, let's try that. So I did just a simple Python M, like a Python 2 version one of just port 80. And lo and behold, that worked. So when I ran it a couple times, it then popped over here, and our reverse shell that was waiting is now here. So this essentially brings us back to the same scenario we were in before for the first part of the challenge, right? So in this case, you would do the exact same thing, right? You would navigate over to, what is this, C colon, oh yeah, what is it, /users/bill, right? And we were looking on the desktop, if I can type correctly here. Right, there we go, and dir, and then we would just type user.txt again, just like last time what we did there. And the same thing would then apply to doing it with the privilege escalation to root, but this time we would use a new tool that we could use for enumeration. So this one here is called WinPeas. So if you look up WinPeas, if I can type it in correctly, this is an enumeration script you can run on a Windows machine to see if there's anything there we can privilege escalate. Now, what we're hoping to see is the exact same thing that Meterpreter found when we ran that first one, and it showed the unquoted vulnerability. So it's essentially doing the exact same outcome, but we're just doing it a different way without Metasploit. So in this case here, you would want to go here, go to WinPs, WinPs exe, binaries, and I believe this is a 64-bit machine, so if it doesn't work, this will probably be the reason why. But this is where you would grab that particular executable. And again, if it doesn't work, we could always try going back to the this one here, probably under release, and do it there, right? I kind of wonder if that's a better choice, but we'll see. All right, let's come back over here. Where were we? All right, so next what we want to do is after we run that exploit, and we had that, we basically would do the same thing again. I mentioned here, we go to Bob's desktop and do all that business. So what we're going to do this time is we're going to actually download WinPs to this directory, and we're going to go ahead and on this victim machine, we're going to try to grab it. So let me go here for a second. Where is that at? There it is. I'm going to grab this location for this one, and I'm going to see if I can clone it. If not, I can just download it, I suppose. Let's see. And I guess we'll put it right in steel mount. There it is. All right, so I don't know if this WinPs X64 will work, but I'm just showing you a way that you can do it, which will give you the same results as the Metasploit one. So in this case, what we're going to do is, because we're on the PowerShell one, because we are here as Bill, we're going to run a PowerShell script, and the -c is for the command that we want to run. In this case, we're running wget, but don't confuse it. It's not the actual wget that you know from Linux. This is actually an alias in PowerShell for the command invoke-web client. I'm trying to think now. I think no, I'm sorry. Invoke-web request. So it's essentially saying I'm going to use PowerShell to reach out, grab this executable, and put it here. But to do that, we have to host it. So let's see here. We're on our machine, and we have that there. There's WinPs X64. I'm going to go ahead and do my Python script again. So Python 3 tac m http.server, and we'll just say 9200. Okay, we'll be listing on that. All right, so now that's hosting this file here, WinPs.exe64, whatever it's called. Okay, so what we want to do is do our PowerShell for that particular one there at whatever the IP address is for it. Okay, so I'll just copy this over, and then we'll screw with the, oh, you know what? We're in that particular one there, so we may have to actually type this out. So we'll say PowerShell tac-c wget, and it's at HTTP, and I need my local address. Are any of these open for me? I should actually do a split command window instead of opening all these particular ones. But, all right, so we need this IP address, and it's on port 9200. So we'll say that :9200 / and then the WinPs, which is right there. So I'm basically pulling it from from the attacker web server, as it were. So we're saying grab this one here with the PowerShell script. So PowerShell tac-c wget blah blah blah. In this case, this is the actual file, but we want to actually name it the name of the file as well. So we'll just say out file and then the same name that we give it. So we'll say tac out file, and I can't remember if you have to put quotes. Yes, okay. Quotation, end quotation, boom. So it should download WinPs64, and then we could just run it from here and see what happens. And there's a similar one that's a bash script for Linux. It's called linenum, and you can do the same type of thing for enumeration of that system. All right, so we do have it here, correct? There it is. Awesome. Let's just run it. And let's see what we see. Now what we're hoping to find is that same exact, what was it called? Unquoted vulnerability or whatever it was called for Advanced System Care Service 9. That's what we're hoping to see on this one here if it runs today. And if not, that's fine. I've still showed you the exact same steps. So as we're waiting here, it may lag. Sometimes these ones crash. These VM, these TryHackMe. Sometimes it bonks those out. So if that's the case, let me explain kind of what's going on after it while we're waiting on it. So what would happen after that, you would run it and it would show an enumeration script that says, we found this unquoted vulnerability or whatever it was, and it would be the exact same one, the advanced system, whatever it's called. So essentially what you would do is you would just grab that exact same Trojan we made with Msfvenom, right? And you would use this exact same PowerShell method to grab that. So you would host it in that same folder, asc.exe, whatever it's called, and you would send it over and you would do the exact same steps. You would stop the service, you would do it again, and all that kind of stuff. But we won't do that because we already did it with Meterpreter, so it's already there. But we're just trying to explain this is a way that you can actually do the exact same thing without Metasploit, right? And sometimes these scripts will run a while, like this one seems to be hung up. But that's essentially what you're going to be using, and I think that's what they used here for access without, yeah, okay, so they run WinPs. There we go. So here's what it would show. Here's the output it would show once you get WinPs running. Sometimes you'll have to restart the TryHackMe VM because sometimes it will bug it out. But this one here will also check and see and show that it's an unquoted one as well. And here they're using a manually found out the service name. Oh, okay. So that's just more PowerShell to find out the name of it. But essentially, you're going to do the exact same thing we did earlier. We're going to stop it. We're going to upload our Trojan version of it and then start it again. Of course, we'll have our listener wait in the wings to be able to do that. It doesn't look like this is running today, so that's not a big deal. You get the idea. You get the actual method and steps that you can do it. And if those hangs up like that for you, just try to restart the VM and try it again from that, because sometimes, again, it bugs out. But anyways, quite a bit of stuff to go through there. It was actually a pretty long video, but there was a lot of in-depth stuff, a little bit more advanced stuff than I've taught usually in some of my other ones. So we learned some different privilege escalation techniques. We learned about some Windows enumeration scripts. What else did we learn? Some Netcat stuff, some Nmap scanning. We learned how to exploit a particular version of software using a site called ExploitDB. We learned how to use Metasploit and the awesome post-exploitation tool Meterpreter as well. And we were able to go ahead and do some basic enumeration and get into Bob's machine, get his user.txt, and then escalate our privileges up to be able to look at root by actually making a Trojan version of an existing service that was running, swap it out for our Trojan one, stop the service, run it again, and it would actually run as system. So it's a little bit more advanced than some of the other stuff that we've done, but a really good video session here. So yeah, so that's it for this one. So be on the lookout for another video in the series. Pop, another server drop, and I'm going to be getting some new gear, and so you may be seeing in the next few videos, I'll be getting rid of these headsets and putting a little pop filter for when I say pop, and getting a decent Elgato Wave 3 mic and stuff like that. So hopefully we'll have that in the next video. So until next time, peace out, players. Keep on popping.